In this video, we're going to review how to complete the squares. Before we do so, we would like to make sure we understand the difference between these two directions. When we say complete the squares, often we're given a quadratic expression, or what we call algebraic expression. Solve quadratic equation, and then we will be given an equation. Equation got to have equal sign, got to have a variable. Algebraic expression does not have equal sign. We don't solve for x, we complete the squares. We complete into a quantity square form, for instance, like that. And we could have some accessories. And within, normally, it's going to be binomial of the sum or difference of two items. Let's look at the example. For instance, this question, if I have x squared plus 4x plus 7, the rule of completing square, I need to have a leading term, I need to have a linear term, and I will leave some space to find the third item to complete the square. The rule of finding the third item is a half of middle coefficient, and I will square that item, or the square of half of middle coefficient. Half middle coefficient, we're talking about half of a 4, which is 2. So we have half of a 4, and we need to square that. We cannot just add something into the equality, we have to subtract to keep the equality going. And now, with these three items, we have x plus 4 over 2 quantity square plus 7 minus 4 over 2 quantity square. Now normally we just write x plus 2 quantity square plus 7 minus 4, or x plus 2 quantity square plus 3. Now this is called perfect square, and we just completed the squares. You do need to know how to get from here as a quadratic expression to here as a complete square form or perfect square form. In our class, in our course, we are expected to do something like this. What if the integral of 1 over x squared plus 4x plus 7 is given, and we need to find the antiderivative. Now, only if you can get from here to here, then we can move on, because the quadratic is really x plus 2 quantity square plus 3. Now I notice, okay, we realize that's a tangent substitution. We're going to let x plus 2 be square root 3 tangent theta, and dx is going to be square root 3 secant square d theta, and then we can finish the problem. But if you cannot get from this quadratic form to this perfect square, can you see we're actually pretty much stuck, and we cannot even realize I have a tangent substitution. So I hope you understand how to complete the square. Let's look at another one. And this one, what if we're given this quadratic as 2x squared plus 3x minus 1. Remember earlier we said when we complete the square, we should have 1 as a leading coefficient. What if I have 2? Then I factor the 2. Then I will have x squared plus 3 halves of x. And again, you just leave some space and copy the constant outside. Often, this constant is not going to do anything. It's not going to be helpful in completing the squares, so I just copy it. Okay, so remember the rule of finding the third term to complete the square. It should be the square of a half of middle coefficient. The middle coefficient is 3 halves. Half of 3 halves is going to be 3/4. Remember to square that. Minus 1 is from here, right? But look what we did. We actually added 2 times 3/4 of square. So that means I need to subtract 2 times 3/4 square. to keep equality going. So this is going to be 2 times x plus 3/4 quantity square minus 1 minus 2 times 3/4 square as 9/16. So I will have a 2 times x plus 3/4 quantity square minus 1 minus 9/8, or as 2 times x plus 3/4 quantity square minus 17/8. Now I completed the squares. So in our class, again, in calculus, we expect to do something like this. For instance, what if we're given the square root, integrand to integrate, which will have 2x squared plus 3x minus 1. And the first thing you do, you're going to complete the square, and then complete this into 2 times x plus 3/4 quantity square minus 17/8 dx. And from this expression, now we recognize this is a secant substitution. I will let square root 2x plus 3/4 be square root of 17 over square root of 8, and secant of a theta d theta. And then we can move on. Okay, let's look at another one. And this one, what if we're given 7 minus 6x minus x squared as a quadratic function or quadratic expression to complete the squares? And at first, you're going to write them in ax squared plus bx plus c form. Means that I need to flip the terms around. Negative x squared as the first term minus 6x plus 7. The leading coefficient should be 1 to complete the square. Right now, I have negative 1. So we will factor the negative sign. X squared plus 6x plus 7. We factor the negative sign. Do not divide it by negative 1. If divided by negative 1, you're changing the algebraic expression. So negative of x squared plus 6x. In this step, I need to consider what the third term will be so that I can complete the square. The rule, again, to find the third term is the square of a half of middle coefficient. The middle coefficient is 6. Half of 6 is 3. So therefore, I should have 3 squared. Plus 7. Now look at what we did. We actually subtracted 9. So I need to add it back to keep equality going. And so now I have x plus 3 quantity square plus 16, or I have 16 minus x plus 3 quantity square. Again, in our class, in our course, and this is what's expected, what if we're given a problem look like this, say 7 minus 6x minus x squared dx, and only if you can complete the squares, then you will realize, okay, 7 minus 6x minus x squared is really 16 minus x plus 3 quantity square, so that can go by sign substitution. And then we can say, let's let x plus 3 be 4 sine of theta, and the dx is going to be 4 cosine theta d theta, and then we can move on. I hope this helps to understand or to review how we complete the squares on quadratic functions.